Whenever I get ready to balance chemical equations, I think there are about 3 different charts that are important. And I'm going to talk about those 3 different charts. There's an oxidation number chart, a polyatomic ion chart, and an oxidation number rules chart. These can all be Googled, and you can get these printed right off the internet. So let's talk about these for just a few minutes. When we balance chemical equations, the periodic table of the elements, which is this right here, tells us a lot. Everything in group 1A, hydrogen, lithium, sodium, potassium, and so forth, these all have a +1 charge, and that means they want to give away an electron to be happy. Those in group 2A, beryllium, magnesium, calcium, strontium, those have a +2 charge, meaning that they would like to give away 2 electrons to be happy. The ones over here to the far right are called the noble gases, and because they have a stable outer shell, they do not wish to participate. And so typically helium, neon, argon, krypton are not participants in chemical reactions. Group 7A, though, these are the halogens, and these are mega participators. See that they've got hydrogen listed over here, that it can be -1, but I want to really talk about fluorine, chlorine, bromine, and iodine. These are big-time electron snatchers, and they all want 1 electron to be happy. How do we know that? If they get 1 electron, then they'll look like the noble gas just to the right. They will have the outer valence configuration. The elements in group 6A, oxygen, sulfur, selenium, these are all -2. That means that all they need to do is get 2 electrons to appear like a noble gas, and that would make them happy. And then you can also see that carbon and silicon can be +4, -4. Usually nitrogen by itself is -3. Yeah, there's some exceptions to this. These kind of get a little bit hazy. When we get into these columns here, these are a little bit hazy and a little bit tricky, but those are some important rules to understand by using a periodic chart. The next important chart that I want you to Google and download would be one on polyatomic ions. It's common polyatomic ions. Maybe you can say these with me. C2H3O2-1 acetate. NH4 +1 ammonium. CO3 -2 carbonate. ClO3 -1 chlorate. ClO2 -1 chlorite. CrO4 -2 chromate. Cn -1 cyanide. Cr2O7 -2 dichromate. HCO3 -1 bicarbonate. HSO4 -1 sulfate, HSO3 -1 is bisulfite. OH -1 hydroxide. ClO -1 hypochlorite. NO3 -1 nitrate. NO2 -1 nitrite. C2O4 -2 oxalate. ClO4 -1 perchlorate. MnO4 -1 permanganate. PO4 -3 phosphate. SO4 -2 sulfate. SO3 -2 sulfite. I think these are good to put on flashcards and just memorize. If a person is balancing equations, it's really incredibly important for the person to recognize these as units, functional units that usually stay together. Not always, but super important nevertheless. Another chart to download off of the internet would be oxidation number rules. This is pretty important, and so I'm going to go over these just for a few minutes. And as I'm balancing equations in subsequent videos, I'll be referring to these charts that I have that I'm talking about right here. So number one, if an element is present in its elemental form in an equation, its oxidation number is 0. If there is only one kind of atom present, then there is no charge. In the rules for oxidation numbers, it says atomic ions equal to the charge on the atom. All that means is that if it says Na plus 1, then that's the charge on it. That's what it means. It's just that simple. Cl minus 1, it means the charge is -1. It wants to receive an electron. Now, what I want to draw your attention to, though, are some of the transition metals in the middle of the chart. Things like iron. Iron can be iron 2 or iron 3, and usually in a chemical equation it will tell you which one it is. So if it's iron Roman numeral 2, then it's iron plus 2. If it's iron Roman numeral 3, then it means it's iron plus 3. It's just that simple. All of the elements in group 1A are plus 1 unless they're in their elemental form, and in that case their oxidation number would be 0. Group 2A, they're all plus 2 unless they're in their elemental form, then their oxidation number again would be 0. Hydrogen is plus 1 when bonded to a nonmetal, minus 1 when bonded to a metal. Oxygen. Oxygen's always -2 except in peroxides where it's -1. Peroxide is O2. It's a O2. Actually, the charge should read O2 -2 here. That's the charge on a peroxide. That's not correctly listed right there. Fluorine is always -1. If a compound is neutral, it means that the sum of all the oxidation numbers of atoms or ions in a neutral compound is 0. Ionic compounds. The sum of all oxidation numbers of atoms in an ionic compound is the charge on the polyatomic. So all this means here is that if you see CO3 minus 2 carbonate, then you don't need to worry about trying to figure out the oxidation number on the carbon and the oxygen. Just know that the whole thing is -2. That is important. And I'll refer back to these as I go through some of my equation balancing. Download these off of the internet, please.